Now I introduce distributed deep learning. Distributed computation also is called parallel processing. Allows us to use the multi-computer resource to work on a single network training at the same time to speed up the training process. There are two typical parallel processing methods. One is data parallel processing, and another one is model parallel processing. In the data parallel processing, we split the servers into two categories. One is the parameter server, another rest of them is a model server. Parameter server is responsible for the update of the model parameters and receive the gradient from each model server and send the model parameters to each model server. Each model server has a whole model. That means they are same, no communication at all. Each model server has its own storage. That means has its own training data. So in the data parallel processing is only communication is between the parameter server and the model server for the model parameter and the gradient. Another model is a model parallel processing is different. If one single server cannot hold the complete model, that means we have to split the model into many small pieces and assign each small piece to an individual computer. Because each server has only part of the model, so to work on the network training, so we have to send and receive from each server. We have to send or receive the model parameters, make sure they work as a single computer. That's a little bit complicated than the data parallel processing. However, we have several ways to reduce the data communication between the servers. One is for the convolutional neural network, we can set up an overlap region between the adjacent machines, computers. That means in this overlap region, we simulate the nodes, neurons here 2 times, but we don't need to exchange data between the two adjacent machines. That's one advantage. For the fully connected layers, we can arrange the server in this way. For example, this is server 1, this server 2, this server 3. In this way, even we update the value at this neuron from all the neurons in the adjacent computer, but we only send one number or one vector. So in this way, we can reduce the communication data between the servers. For the distributed deep learning, because the Q-learning is you can use the regular neural network to search for the optimal policy. For the distributed deep Q-learning, has two differences from the regular network. So when we handle the distributed deep Q-learning method, we have to consider 2 things. One is the replay buffer. Replay buffer means we each simulation we have to store or save the result in the local server. So if you can save the replay the experience in the local disk. So this method is the same as the data parallel processing method. By the way, data parallel processing is more popular than the model parallel processing, because the model parallel processing only for the larger company like Google and Microsoft. They have a huge model. They cannot use one single server hold the whole model. So they have to use the model parallel processing method to split the model into many small pieces to speed up the simulation. However, in most of the application and the research we can use, we just use the data processing. It's much easier. Like we mentioned, that we only need the exchange between the parameter server and the model server. We can only exchange the model parameter and the gradient. That's for one. For second, is the the deep Q learning uses two networks. So one is a Q network, another one is a target network. However, target network is it's just one forward path to generate the target. So we don't need to train the target network. So that's why we can put the target network in each model server. So still, we use the data processing method, same as we described previously. The detailed implementation of the distributed deep Q learning method is here. Roughly, this is two parts. One part is this, say this is the parameter server. This is the model server. The parameter server just is responsible for the update of the model parameters and receive the gradient from the model server. And the model server hold all the complete model, and they also include the Q network and target network. And just to store the replay experience is a local hard disk. So from the local training data, then model server calculate the gradient for the local batch training data. Once we get this this gradient, and then send this gradient to the parameter server, and the parameter server uses the new received gradient and then update the model parameters again, and use this way. Then finally, we get the convergent result and speed up the network training by using multi-model servers. For more details, please check with this reference. Thank you.